super good.
Super good. That's good. What'd you get up to today?
I went sledding today.
Sledding. Okay,
Sledding
cool.
is fun. There's a
Yeah.
really good place for sledding.
Where is that?
I forgot, but
Is it a big hill?
yeah, it's a big hill. And I went up between the trees and start. And it was so fast that I hit a little ramp thingy and I flied 1 inch up in the sky. I flew 1 inch up in the sky.
I flew 1 inch into the sky. Oh well, you were going very fast then.
Yeah,
well, that's cool.
And also there was ice all over the road. So when I got to the road, it slid even faster.
Good. It slid even faster.
It slid even faster, so it was like.
Yeah, the ice is makes you go very, very quick.
Almost no friction, but.
So do you have a sled?
Yeah.
Yeah. What kind of sled? Describe your sled a little bit. 1 person, 2 person. What is it like?
It's a 1-person sled, but I rode with my mom as well.
Yeah, cool. So it fits 2 people. Yeah, that's cool. Sounds good. Probably goes faster that way.
If there is 2 people, it's very cramped.
Cramped, but probably faster, I think, with the extra weight.
No.
You don't think so?
Slower, because there's more friction.
More friction, so slower. Yeah, maybe. How much snow is there, do you think?
About 1 centimeter thick snow.
Okay, great. Has it been snowing recently or even today?
It had been today.
It was snowing today.
Today.
Okay.
So there is a lot of snow. Like.
Yeah, lots of snow, sledding in the snow.
Hey, how come giant snowballs don't fall from the sky?
Sometimes they do, or sometimes like it's kind of snow and ice. These snow ice balls are called hail.
Oh yeah, hailstones.
Yeah, it's quite can be pretty dangerous because they can drop and dent your car or I don't know, hurt your head if they land on your head.
Window.
Yeah.
So when it is
hailing.
When it is hailing, you must wear a safety helmet, or your brain might get smashed.
It's true. You gotta wear best car. Best car safety helmet. Yeah.
If there is, hey, I got an idea.
Run with your hands. What's up?
You wear a helmet that is attached to a spring. And if hail hits the helmet, it springs off and bounces off the hail.
Yeah, that could be helpful.
Maybe. If you attach a very strong gear maybe if you attach a flamethrower to your hat, it might melt the hailstone while it was falling.
Yeah, that is true, but that might burn your head. Might cause other problems.
Yeah, maybe if you attach a leaf blower to your head and then blow the hailstone away.
Yeah,
but then it will be super loud. You have to wear ear protection.
Yeah, you have to wear earplugs, and it might work, but I think a regular helmet might be better.
I know. You can wear a chainsaw helmet.
Cut the hail when it falls down?
Yeah.
Yeah, that'd be good. Dangerous, very dangerous, but maybe useful.
I know. A laser helmet. A beam of laser blasts off from your helmet and hits the hailstone and burns it.
Okay. There you go.
Melts it.
Yeah, that might be nice.
Laser helmet.
Laser helmet.
Best car would help more because
I think so. Yeah.
Because it causes a lot of fuel to make that powerful lasers.
Yeah, it's very powerful. Lots of protection.
Hey, maybe nuclear fusion can power that up.
That is true. That's a good segue. Let's open this nuclear fusion test that NASA.
Nuclear fusion is cool.
It's hot.
So
it is both cool and hot.
It is Is lava more hotter or nuclear fusion more hotter?
Just hotter. Is lava hotter than nuclear fusion? I don't know. I imagine nuclear fusion is probably hotter.
So nuclear fusion versus. So what if they have a contest? Nuclear fusion versus nuclear fusion blaster versus liquid nitrogen supercooler.
Oof. Yeah, hot. The hottest thing versus the coldest thing. I don't know. They cancel each other out.
May I saw a video where they fire red hot almost as hot where they fire up lava hot flamethrowers versus liquid nitrogen supercoolers, and the liquid nitrogen won.
Well, that's cool.
First, the flame was going like, and the liquid nitrogen covered up the flame, and the liquid nitrogen literally went inside the flamethrower. It damaged the machine thingy, and the fire just got put out.
Yeah, it was. That's another word. Extinguished.
Yeah, extinguished. Maybe there is a thick sheet of ice in the nozzle that the flame can't go through, and there's no oxygen for the fire to come out. So the liquid nitrogen won. But what if there was a nuclear fusion blaster versus liquid nitrogen supercooler?
Yeah, I don't know. What would happen then?
I guess the liquid nitrogen will be so hot it will vaporize away, and the nuclear fusion will be so cold it would freeze up.
Yeah, that's true.
And
so that's the whole problem in itself.
Maybe there will be an explosion.
Oh.
And there is also a thing that is colder than liquid nitrogen.
What's that?
Liquid oxygen.
Oh yeah, I didn't know that was a thing. So that's cold. One of the coldest materials on Earth, or
almost as cool as absolute zero.
Oh, that's interesting. Absolute zero. What is that? What does that mean?
That's a temperature that atoms can no longer move.
Everything is just still. Can't move at all.
Atoms usually move really fast around, and the hotter it is, the faster it is. So in nuclear fusion temperature, it might went on the speed of light.
All right. So let's go.
What if liquid oxygen meets with its arch enemy, nuclear fusion?
Nuclear fusion. I don't know. What would happen? Massive explosion?
Liquid oxygen is very reactive, explosive, and other kinds of stuff.
Yeah, so it might be a huge explosion.
Put it in a barrel. It might blow a hole in the barrel.
True.
Liquid oxygen might spread out and become a liquid oxygen blaster.
Oh, what would you do then?
Then that's a liquid oxygen blaster.
True.
And that versus, and what if that combines with liquid oxygen? What will happen?
If that combined with liquid oxygen, I don't know. Yeah, what would happen?
Yeah. I heard that they use it to cool down lava and hot stuff.
Yeah, they could. That's possible.
But liquid nitrogen is a lot easier because it's more safe.
Yeah, it's safer. I agree. So let's turn to the nuclear fusion. Read about what's going on there. Do you have the article?
Yeah.
Nuclear fusion. All right.
Thermonuclear fusion reaction. Whatever. One day, thermonuclear fusion might save humans' life. I watched this video about stellar engines.
Stellar engines, like what is that? Star engines?
It's an engine. It's a super rocket that is used to move the solar system. The good thing, fortunately, that doesn't have to be hard.
Yeah.
because we only have to move the sun, and everything will be glued together by gravity.
Yeah, that's good.
But what if the sun is going too fast and the planet stopped rotating and flung off the bat?
You mean if the planets stop being held by the sun's gravity and they just kind of floated off into the into the galaxy?
Huh. Maybe an asteroid might come by, and if the Earth is orbiting like this way and the asteroid is coming this way, kabam!
It would just what you think destroy it, or just kind of hit it off course, make it go float off in another direction?
Maybe it'll smash it into 1,000,000 pieces.
Yeah, 100 million pieces. Yeah, that's possible. What's the biggest asteroid? Do you know?
Maybe the Earth can bounce it off and make it head straight toward Mars. And then Mars bounces it off, and then Venus catches it, and Venus bounces it off, and it hits Mercury, which is the smallest planet, so it gets destroyed.
Yeah.
Kabang. Or maybe the Mercury will bounce off that and make it head straight towards the asteroid belt, and then the asteroid will orbit there.
Yeah, asteroid would just kind of join the asteroid belt and go around.
Maybe it will go so fast that it crashes into the other asteroid, and it makes a donut shape of the asteroid. Then the asteroid
goes hole in the middle.
Then the asteroid goes so fast that it just hits Jupiter and just goes through it.
Yeah, goes all the way through Jupiter.
And Jupiter.
That would be difficult.
And Jupiter's mass will flung off into outer space.
Fling off.
Some of them.
Yep. Yeah, some of the mass will fling off into outer space.
Then it will hit Saturn's rings and ruin it. And then go through Saturn and go through Uranus, go through Neptune, and goes through Pluto. Completely smashes Pluto into 100 million billion pieces.
And then, what's after Pluto? Do you know?
Oh, yeah.
You heard of the
Ellis.
Kuiper Belt?
Yeah, the Kuiper Belt.
Kuiper Belt.
And head straight toward the Kuiper Belt and bounces off teeny tiny asteroids and just go like.
Yeah.
It might just go on like that forever. But
no ending. Yeah.
But it might mess up the Kuiper Belt, or else it will just escape or head back into the solar system. If it escapes, then it will head toward deep space, where stars and planets and asteroids and black holes can catch it. And also the thing that will destroy, the thing that will make it bounce off the hardest will be what was it? Neutron stars.
Okay. It'll bounce off neutron stars.
Because their magnetic fields are super strong. And it might vaporize the asteroid or make it bounce off really hard. It'll just go super fast and go through stars and head into the mouth of a black hole and go super fast in the black hole that it pops out, that it makes a hole in the black hole and it escapes and nothing could make it stop.
Yeah, it just continues forever.
Yeah, it might go out outer space, go out the observable universe, and then goes through nothing.
Yeah, goes to the edge of the observable universe. That would take a long, long time.
Yeah.
Go to the edge of the observable universe. Great. So yeah, let's if you want to crack that open, we can start reading about nuclear fusion.
There has been a relentless quest to find sustainable energy sources in the past decades. One source of energy that has far eluded scientists
eluded
scientists
means they can't find it. Eluded, can't find.
eluded scientists is nuclear fusion. This is the holy grail of clean energy. Generations of physicists have tried to replicate its reaction. Scientists in the USA said they recreated the power of the sun for a minuscule fraction of a second. Powerful lasers blasted a tiny target to create a reaction. The burst lasted just 100 trillionths of a second, but it created 10 quadrillion watts of power. That's a lot.
That's a lot of power. Yeah.
I guess
10 quadrillion.
I guess if you use all of that power at once, it hit straight toward Mars and blew it up.
Yeah, that's wild. And that was that much power from 100 trillionths of a second.
Yeah. If they use that power at the same time, it might collapse into an energy ball and then might blow up everything in its path.
Yeah.
Maybe if it heads toward the sun, the sun will be an electric ball, and then the sun might combine with the electricity, and the sun might fire electricity instead of solar flares.
Agreed.
Maybe, but if the electricity goes through the sun and reaches its core, the electricity might zap the core, and make it even hotter, and the sun will expand, and the earth will be hot as Venus.
What will that do to us? That'll make life kind of unlivable, huh? If it gets that hot.
So you have to live inside refrigerators.
Yeah. You have to, and then probably put those refrigerators under Antarctica, under the ice.
Yeah, but the sun might melt the ice, and if the sun blows up if the sun gets smaller, the temperature of Antarctic will drop super fast. That the water have no time to escape, just freezes.
Okay, good. If the sun shrinks means get smaller.
And if that sheet of ice is really thick,
yep,
it might trap us inside the refrigerator. We might have to use a sledgehammer to blast it open.
Yeah, I would not want to live in a refrigerator. Because also you'd have to have millions and millions and, maybe a few billion people. Imagine all the people on Earth squished into a little refrigerator under the Antarctic.
After that, you can't use your legs anymore.
Yeah, not allowed to have legs. What do you eat? How do you cook food? You just eat ice, maybe?
Maybe human will turn into penguins.
Yeah, there you go. It's a good way to optimistic outlook. Humans could become penguins, and then what will penguins become?
Penguins might become humans.
We'll just switch places. Yeah, that might be fun.
Penguins might be bunnies. Penguins might
learn how to fly. Maybe they'll learn how to fly.
Penguins may be plastic.
Yeah, they could turn into inanimate objects. Plastic. Inanimate objects.
Yeah, that will be unfortunate for the penguins because they'll not be an animal anymore. They won't be a creature anymore.
They won't be an animal at all.
At least it would be like dead.
They would be, you can say, inanimate objects.
Inanimate objects, but
Yeah.
that's pretty much dead.
Yeah. Inanimate means not animate, not alive.
Yeah.
You know.
And not alive stuff are pretty much dead.
Not alive things are dead. Yes. Yeah. Or yeah. It's a good question.
So that means this paper is dead.
Yeah. Yeah, I guess so. I guess you're right. Or it was never alive. Didn't ever have life.
Yeah. Maybe it is alive because it was made out of live stuff.
That's true. What was it made out of?
Wood. And wood came out from trees. And trees are alive.
Wood comes from trees. That is true. The paper came from wood. Wood comes from trees. Trees are alive.
Trees are made out of wood. Wood is made out of trees.
Yeah, both are true.
And papers are trees. Trees are papers.
Yeah.
So this must be a living object.
Yeah, well said. Good logic. It's a living object. I think we gotta stop there. Coming up toward the end.
I think it feels pain when I just hits it.
It might feel a little bit of pain. It's hard to tell.
There's a lot of sound.
Yeah,
that sound might be the scream of the paper.
Could be. So I gotta get ready for another class, but we'll pick it up on Friday. Friday?
Okay.
Yeah. Yeah, continue. Chat about this, chat about penguins, chat about inanimate objects. All right. Enjoy the rest of your night and see you next time.
Goodbye.
Bye-bye. Oops, there we go.